Hello and welcome to the 4th episode of STEM for Girls by Girls in STEM. I'm your host, Serena Beri, and in this episode, we'll be talking about thinking outside the box and different solutions to face problems in the real world. So this episode is titled, No Fear Girl, Think Outside the Box. What is the importance of problem solving? Problem solving is a critical part of any job. In any job, you'll need to solve problems fast and quickly and come up with ingenuitive solutions. Problem solving enables us to think ahead and plan for the future complications. It also shows independence and creativity in the field. It also allows us to come up with ingenuitive solutions to problems. So, how can you improve your problem solving skills? It is important to focus on the solution and not the problem. If you focus too much on the problem, then you might get overwhelmed. So by thinking of the solution, it is easier to come up with different solutions. You should also simplify the issue. You can do this by brainstorming or mind mapping. This is a technique where you can just get all of your ideas out in front of you and then think through them. You can also conduct role-play scenarios where you can create issues and solve them. An example of this is the FLL team Pajama Llamas 3D printed a robot head that serves as a solution to the lack of social aspects that astronauts face. How do you approach a real problem? There are 7 steps to problem solving. The first step is to identify the issue. This is the important step because without knowing what issue you're trying to solve, you won't be able to solve anything. The next step is to determine what causes the issue. By determining the causes of the issue, you'll be able to pinpoint the exact causes that you need to address. The next step is to develop solutions to the issue. By having a list of solutions that you don't need to develop right away, you'll be able to think of multiple ways to address the issue. Next, you want to select one solution to focus on and develop that solution. You can develop it by researching what has been done before. Next, you should implement the solution and then evaluate the outcomes of the solution. So, the first step is to identify the issue. Now we'll be looking at a real-life problem and how we can go through the steps of problem solving to solve this issue. The issue we are looking at is that healthcare needs and costs are growing around the world. So the next step is to determine what causes the issue. The cause of the issue is that the aging population is rising, and also chronic diseases are rising with this because as patients are getting older, it is harder to treat them. In fact, the global healthcare spending is projected to reach nearly $9 trillion by 2020. Healthcare is also increasing due to the increased costs of outpatient and emergency room care. The third step is to develop different solutions to the issue. So some solutions could be creating cost-sensitive medical innovations. This would mean creating cheaper devices that could help patients. You could also develop cheaper procedures and ways of caring for patients. An example for this is recently, more nurse practitioners and other medical workers are being able to treat patients, which decreases the amount of people who need to see patients. Also, you could discover cheaper drugs and medicine, which would help reduce the price of medical care. So the solution that we will be looking at is finding creative, cost-sensitive medical innovations, specifically looking at medical additive manufacturing through 3D printing. This is a great solution because it helps better patient outcomes and results in less time in the operating room, which creates reduced costs for patients. There are many applications of 3D printing in the medical field. The first application is the general application where you could 3D print surgical tools. There's also anatomical modeling where you can make patient-matched models for medical imaging studies. This would be a great feat because the surgeons would be able to look at a specific patient's organs. It will also help with surgical planning where you can make patient-specific templates for a surgical plan and actually perform surgery on the 3D printed model. And then by doing this, you could find future complications and ways that you could avoid these complications during the actual surgery. Could also make active and wearable devices. An example of this would be wearable sensors that the patient could wear. It is also being used for precision prosthetics where 3D printed patient-matched implants and prosthetics are being used to help specific patients. Bioprinting and tissue fabrication is a new way that 3D printing is being used where you're using materials that incorporate living cells into the 3D printing. And finally, permanent implants such as metallic implants can be 3D printed. So, step 5 is to research what has been done before. In 2000, hearing aid cases were being 3D printed. This became an industry standard a few years later, as it was a cheaper way to create and manufacture hearing aid cases. In 2017, doctors started 3D printing polarized contact lenses epileptic patients would use, and it helped reduce seizures. So the sixth step is to implement the solution. So what are manufacturers doing right now? Smaller hospitals are starting to work with contract manufacturers for segmentation to prepare files for 3D printing. Larger research hospitals are starting to have their own in-house 3D printing laboratories. Therefore, they don't need to go to an outside source to 3D print. Bioengineers are also doing research for applications such as bioprinting and tissue fabrication. So the seventh step is to evaluate the solution. Now, we can't evaluate the solution right now, but we can look at a real-life example, which is the Mayo Clinic. Mayo Clinic is a manufacturer for anatomical modeling, virtual surgical planning, and some Class II medical devices. They have said that 3D printing allows them to collaboratively solve complex medical and surgical problems. It has also led to improved care, innovative approaches, less time in the OR, shorter hospital stays, and smaller incisions. Overall, 3D printing has really helped develop the medical field. However, there are some challenges. Some of the challenges for medical 3D printing are listed here. The first one is regulatory environment. There is little history of medical 3D printing applications as it is such a new and upcoming field, so regulations are still being formulated by the FDA. Reimbursement is also an issue as costs are not reimbursed through health insurance since it is such a new and upcoming field. Technology could also be an issue in the future as materials, processes, and software for 3D printing is continuing to be evolved and advanced. This software could also be costly. Finally, there is not a qualified workforce as this field is so new and there hasn't been a blending of biology and engineering recently. So the future of 3D printing is really fascinating, and it starts with apps that could take images to create 3D models. This would be really progressive as we wouldn't need the use of big, expensive MRI or CT scans. New materials, including printing different silicone with physical properties, is also in the future applications of 3D printing. 3D printed ceramic implants that gradually disappear and become actual bone is something that doctors are trying to figure out in the future. There's also a time-release drug delivery system that's in the works. This would specifically help patients who are taking a lot of medications, and it would help relieve their stress of having to remember each medication and drug that they are taking. And finally, hologram 3D printing is very much in the future, but it is something that we are looking forward to as doctors. Now I am joined with Mr. Vellal, who is the co-owner of 3D Educational Services Incorporated, and he actually built his own 3D printer. So what is 3D printing?
Well, first of all, Serena, thank you very much for inviting me. So in a traditional way of making or manufacturing, you would take a block of plastic and then you kind of like carve out the metal that you don't, material that you don't need. So that is known as subtractive manufacturing. 3D printing is also known as additive manufacturing, where you're depositing layer by layer of the material. You melt a layer of plastic and you kind of like add onto this. So this is known as additive manufacturing. So if you see here on a 3D printer, so the material is fed through an extruder where a piece of plastic is pushed through, and the plastic comes through into a what is known as a hot end, where it kind of like melts the plastic and it's depositing layer by layer. Now, in a 3D printer, you have different components. In this case, you have a bed that is which is hard enough to hold the plastic on firmly as it's printing, so that it doesn't displace apart. At the same time, the printer is controlled by a small mini computer inside, which kind of like controls the movements as to like how it needs to deposit the plastic. Now, I'm going to explain to you what is the process. How do you start? So the first step is to design a 3D part using a CAD system. So in this case, I use what is known as Onshape. I designed a 3D part using an online CAD software. A CAD software is typically used to design a 3D part using various methodologies. In this case, it's known as solid modeling. So after I have designed, the next step is to do what is known as slicing. So I generate a file which kind of like creates, remember, I told you it deposits layer by layer. So I need to design each and every layer, how it's going to deposit. So the way that is done is what is known as a slicing software. So the software, you add the configurations of your 3D printer, specific to your 3D printer, and you do the setup and then say what is the speed with which you want to print and what is the material you want to use. And the software gives you the layer by layer definition of what needs to be, what is going to print, what is going to suggest. Okay. So in this case, if you see here, so this is showing us the layer by layer definition of a particular part that I designed. And once that's the part is designed and you generate what is known as an STL file, which is an input to the slicer, this generates what is known as a G-code file. A G-code file is what is input to the printer, and in this case our printer has an SD card, so you copy the G-code file and put it into the control panel and you choose which file you want to print. So, and once the printer starts running, so it's your part is being made. So this typically the challenge of 3D printing is like it's going to take time because it's a laborious process. And once it does, you just remove the part from the printer, you got it, right? So now some of the things that you need to consider are what type of materials to use. So in this case, we use what is known as polylactic acid, which is a derivative of corn or sugarcane. This is a biodegradable plastic, and our objective is to bring 3D printing for the masses, especially in the education for middle school, high school, for students who are interested in to get into the STEM areas, and hence we use PLA. So there are other materials like Legos, which is made out of ABS, which is slightly is not a conducive way to use in the classroom because of the vapors that it generates. So hence we use PLA, which is much more user-friendly for education. Now, I want to talk a little bit about like your objective of like problem solving, how 3D printing can be used for problem solving. So 3D Educational Services also designs and provides robotics kits for middle school and high school and community colleges. And some of the things is like we have designed our own robotic kit for middle school, for which the parts are 3D printed. So we provide the student the robotic kit where they assemble the robot, and then they do the programming of the robot, and they go through a series of challenges, and we also demonstrate to them how to design a particular attachment that can be used for various types of sensors. This is done using a CAD program where the students can go and design the attachment for the sensors, and we demonstrate with one and give the students a challenge. So here's their problem. So this is like a real life problem that the student need to understand how to how the robot functions and what is the particular type of sensing that needs to be done. And to that aspect, they need to design an attachment that can effectively solve the problem. So to that extent, so we have two different kits, one for middle school and for the high school. For the high school, the challenge is a lot more. So we have much more complex challenges. We use a Raspberry Pi, which is a mini computer. So, but this also gives them a lot more flexibility in the and also the amount of challenges that they can address. So this is close to realistic as you can get in the classroom. So our objective is to kind of like present the students with a hands-on activity that they could learn, and provide them the tools and technologies where they can go and understand and solve any particular problem that they see. So we do have a few of these. I would like to talk a little bit more about, like, I know you touched upon the medical aspects or the application of 3D printing in medical technologies, but I would like to talk a little bit more about, like, how it's used in different industries. There is a wide array of industries that have adopted 3D printing. One of the big ones is automotive. So if you look at automotive, the reason is, like, they can combine multiple parts into one, because additive manufacturing or 3D printing gives the designers an ability to kind of, like, make more complex parts that they could not have made using traditional manufacturing. So here is a simple bearing. All of this was printed in one piece. Wow. So that is the kind of the depth that you can expect. And here is a gear system which can literally function once it comes out of the printer, right? So the other industry is the toy industry. So who doesn't like to have a toy, right? So now students can actually, there are websites where you can download, and if you want, you can make the modifications for the toy, and you can print them as well. So that's another big industry. Now, movies is a significant industry, because, like, the Iron Man suit was designed and 3D printed so that, like, instead of 3 months, it took them 3 weeks. So it also reduces a lot of time, because through the traditional manufacturing, you have somebody who is working on it. So in a 3D printer, you put in the file, turn, and fire the print, and it's running on its own. So nobody needs to monitor it. Whereas, like, in a traditional manufacturing, you have people working on this to make sure things are working, and they have to do a lot of times, especially in the movie industry, they have to do a lot of these activities manually. So this kind of, like, automates the whole thing. And so that is, movie industry is adopting this in a significant manner. The other ones are obviously the education, which we talked about, how it can be applied. You talked about medical, so space. Space is one of the big industries. So the challenge with respect to space is, like, it is hard to haul all the material from Earth into space. So as opposed, if you can take the just a raw material, you could print whatever part that you would like. Space, as well as, like, people are experimenting, MIT and other institutions are experimenting, printing with the material, like, say, for example, sand, or even like a soil, right? So if it's on the surface of the moon, so you could use the material that's available there and construct habitats. And so that's a significant game changer with respect to 3D printing. There is one more I wanted to bring about, but I think that's good enough for the food. So yeah, food. Food is a significant, kind of like a interest, especially, it's not only girls, it's also boys, because, like, people who, they have their own preferences with respect to, what type of food they want to eat, and this gives an ability to print the food. At this point, mainly the experimentation is being done for people who have diet restrictions. So they know that, they don't have to, they can get their diet on a meal by meal basis. So you can expect, pretty soon restaurants providing you the meal based on your diet restrictions. You could probably order it over the phone, and then based on that, they can provide you. Or you can have a printer in your house that 5-10 years from now, that can make the food of what you would like. Okay, so
thank you so much for being here and teaching us all about 3D printing.
You're more than welcome. Thank you.
Thank you. So now we are joined with Amita, who is actually a member of one of our local FLL teams, the Pajama Llamas, and they actually use 3D printing in their project for space. So Amita, what did you create?
So for the 2018-2019 First LEGO League season, it was into orbit, so it was all about space. So for our project part, we decided to tackle the social isolation aspect of astronauts being in space. So we talked to a couple of experts. We talked to Dr. Mazrin Banaji from Harvard University, and she told us that this is a good idea, and it would be good to involve all of the 5 senses that humans have and how we can improve those senses of astronauts in space. And we also talked to world-renowned Canadian astronaut Chris Hadfield, and he told us that this is a very significant problem for people in space, and a lot of astronauts have come back from space and have had issues and depression, including depression, anxiety, suicidal thoughts, and all of that's really important. So our team created Clashed, which is a multi-sensory experience. So we include a bunch of different technologies in this, including one of our own. So I'm going to start off by explaining like the other ones that we had. So we have animatronic pets, which help with touch. So astronauts can feel like they're more at home, and animatronic pets show similar feelings and emotions as real pets, so that can be really helpful. And for smell, research proves that a single preferred fragrance can really do the job. So scent generators are a good fix for that. And for food, NASA's already doing a really good job giving a variety of options for astronauts so they can take almost whatever they want up to space with them. So this is a creation of our own. This is a prototype. So our idea was basically there's a robot on Earth, and an astronaut will take a VR headset and controls up in space. And this has a 360-degree camera head. So the astronaut will be controlling the robot up in space while the robot's here on Earth. So they can travel around with friends, family, and that's a really good experience for them, so that they don't feel like they're just stuck on a rocket, spaceship, whatever you want to call it. So this would probably be a really big help for them, saying that they'll feel more like they're back at home here on Earth.
Mm-hmm. And what are the different components of the robot that you made?
So we have the base, and then we have a pole so that it has a little bit of height. So this is probably the most important part, which is our head. It'll have cameras on all sides, and this is actually 3D printed. So we have a reason for why we 3D printed this. So we didn't find something that we felt would show exactly how we wanted it. So seeing as with 3D printing you can make basically whatever you want, we thought that this would be a really good idea. So this is actually really cool. So I think that was really important. Mm-hmm. That was cool.
So your team actually was the 3rd place champions at States at Massachusetts. Mm-hmm. What was that experience like?
That was really cool. Definitely something that none of us had experienced before. So it was really fun. We got to go to Legoland near San Diego in California, and we had a 3-day competition there. And we got to meet people from all over the world, Australia, New Zealand, countries in Africa. So that was really fun.
Mm-hmm. And what do you like most about being on an FLL team?
Being on an FLL team, you learn a lot of things that you might not learn in other out-of-school activities that you do. So FLL does teach us a lot of how to work together as a team, and how to be good at speaking, and all of those things that are really important. And it also does teach us, some basic programming and project scientific skills that through the scientific method and all those kinds of things, which are really fun.
So you seem to be really involved with STEM. How did you first start off in it?
So it was always something that I was really interested in, and I'd always seen, my brother and other people who were really interested in this kind of stuff, and it really excited me. And being a girl in STEM it's really cool because it's not something that a lot of people feel interested in. So if we can get more people to do this with us, that would be really fun. So being in FLL has been a really good experience, and I can't wait to continue. Mm-hmm. And more in robotics. So.
Do you have any advice for girls who maybe are too scared to join STEM or who just haven't thought about it as a career before?
Don't ever be scared to do it. It's something that you're gonna really enjoy. It's not something that you'll just be like, oh, you know, I did it, and it's not like you're not gonna like it either, because it's not like you're just doing math, or it's not like you're just doing science. You're actually learning to become a person. It's like, and it's also with people who you you'll start to, you know, make new friends, and those are probably people who you're going to spend more time with, and then, you know, that's what I feel is like really important about it.
Yeah, and that's great advice to all the young girls who are maybe too scared to join or just don't know how to get involved. So do you think FLL is a great way to start getting involved?
It's definitely a great way. And it's just the beginning. Like, this is just a little bit of what it really is. So that's cool.
Has your team done any outreach?
Yeah, so our team has, when we went to San Diego, we talked with a lot of teams from, you know, like out of the United States, so that was really cool. And also in Argentina, one of our team members is from Argentina. We managed to get a video conference with a brand new team from Argentina, and we were able to help them, mentor them a little bit. They're called Flecha Cósmica. So they actually managed to win the Argentinian competition. There's not that many teams in Argentina, but they only have like 1 or 2 competitions there, and they actually managed to qualify for the world competition in Houston this year. So that was really cool.
Wow, that's great. So do you have any future plans for your team, or what are the goals for your team?
So for us, like we already know each other really well, so that's really good, and like getting us to work together, and so that's probably something we've already, you know, gotten like comfortable with. So now it's really on all of us. Each one of us have our own goals. So for me personally, it's like being able to speak better and being able to, you know, not feel scared to do certain things. And our team we all help each other in doing that. So that's really cool. And us as a team, obviously we want to succeed and win, but that's not all it really is for us. It's more like, you know, spending time together, and that's really fun. So we probably want to spend more time together. That's really our goal.
And does your team have any ways that they help get more girls involved in FLL or in STEM?
Yeah, we go to a couple of fairs around the place. We go to some outreach events where we can talk to girls about STEM and getting more girls involved in what we're doing. So
that's great. The more girls that we can get involved in STEM, the better. So thank you, Amita, for being here.
Thanks for having me.
And stay tuned for our next episode, where we will talk about global outreach and what you can do globally to help spread the message of STEM.